Okay, welcome back. To finish off this unit, we're not doing lesson 4.3. We're only going to be doing lesson 4.4 to make the unit a bit shorter. 4.3 is not essential for next year. 4.4 is though. So that's why we're going to be doing it. So right now, we're going to be, for this lesson, converting linear equations from standard form. So right now, we're going to be receiving an equation that's going to be in this new format for us called standard form. And then eventually this is going to move on and become the standard form for quadratics. But right now we're just practicing with standard form for linear equations. So what that looks like is that we're going to be given ax plus by plus c equals 0 in some form or another. This ax is actually my mx from my y equals mx plus b. This by is my y value from y equals mx plus b. And this c value is the b from y equals mx plus b. So what we're going to be doing is taking this standard form and turning it into the linear equations that we're used to, that y equals mx plus b. So what we're going to be doing is moving the mx and the b to the other side of the equation to resemble y equals mx plus b, because we want our y to be by itself on one side of the equal sign. So now we're going to practice some of these equations, but first let's get used to this format of ax plus by plus c, and just fill in those variables off to the side. So our coefficient for a is 3, for b is 2, and for c is 10. So really what the most important thing to identify is this y value, and understand that that y needs to be isolated by itself. It can't have that 2 in front of it. So we're going to take standard form and turn it into slope y-intercept form by isolating for that y value. So let's see one of them in example. A, where we're going to take the y and we want it by itself. So in order to isolate it by itself, we're going to take the 4x and the positive 2, which is my mx and my b, and bring them to the other side of the equation. When we do this, we'll have y, which is by itself on the left side, and we always have to remember the format that we write it in, mx plus b. So my mx, I'll find my mx, which is my 4x, but because I moved it to the other side of the equation, it's now a negative. Same with my positive 2, that's my b value, which is the y-intercept. It goes at the end, but now it's a negative. And we're done. So it's really not that complicated. It's going to get a little bit harder when our y value has a coefficient in front that isn't a 1. So let's see some examples of that. So for our next example here, for c, again, we're going to identify our y, keep it by itself on the left side, bring everything else over, change the signs. So I'm going to be left with a 10y equals negative x, positive 30. But now there's a problem, because it's not y equals mx plus b. It's 10y equals negative x plus 30, or mx plus b. So we have to remember our rules of opposite operations and isolating for variables, and get rid of that 10 in front of that y. The 10 right now is multiplying the y value. So to undo that multiplication, we're going to have to divide. And what we divide on the left side, we have to again do on the right. So we'll divide all the terms on the right by 10. So now I'm going to be left with y is equal to negative x over 10. That can't be reduced. 30 divided by 10 is 3. One more example to finish off conversions from standard form into linear equations. We'll take 6x, bring it over, negative 2, bring it over to the right side. We'll be left with negative 3y on the left. So negative 3y, we don't change the sign because we're keeping it on the left. The negative 6, because it used to be a positive 6. And now negative 2 is going to turn to positive 2. Again, we have a coefficient in front of our y that's not a 1. So we'll have to divide every term by that coefficient. So by that negative 3 in order to remove it. Negative 6 divided by negative 3 is positive 2. And then positive 2 divided by negative 3 is negative 2 over 3. Or you could write the decimal value. So now we're going to move on to a word problem and see why it's sometimes important to be able to alter our equations to isolate for a specific variable or to turn it into y equals mx plus b in our case. So right now, tickets for a local theater production are $2 per adult and $1 per child. The total revenue can be represented using the following equation. 2x plus y equals r. Now let's pause for a minute. We just found out that it's $2 per adult. So in my equation, the x is representing the number of adults. Because I know that it's $2 for every adult. This y is representing the number of children that are going to the show. Because in front of that y value, there's a 1, which is $1 per child, which is 1y. R is representing the total revenue. Revenue meaning how much money the production or the show is making. So this formula includes the adult and children and their price to equal the total amount of money that is being earned. So R represents the revenue, X represents the number of adult tickets, Y the number of children tickets. The theater wants to bring in a revenue of $750 for each of the next 3 shows. So they want to make sure that they make $750 to run that show. The number of adult tickets sold for these shows is 200, 225, and 175 respectively. The first step is going to be to write a revenue equation in slope y-intercept form. When it's asked me to take the equation that's given to me and isolate for y to turn it into y equals mx plus b, the reason why I would isolate for y or get y by itself is that I would need to find the number of children's tickets that need to be sold. So I'm going to take my equation, 2x plus 1y equals r, and I'm going to rearrange it so that I turn it into slope y-intercept form, or y equals mx plus b. So like we did earlier, I'll take my mx plus b and bring it over, leaving y by itself, turning the positive 2 into negative 2x plus r. Now with this equation, it can be very useful in solving for the revenue or solving for y. Right now, solving for y is very easy because it's already isolated. The next question is asking me, how many children's tickets must be sold so that they achieve the revenue target? Well, what was the revenue target for those 3 shows? The revenue target was $750. And for the 3 shows, I sold 200 tickets to adults, 225, and 175. So we're going to separate this into show 1, show 2, and show 3, which will use the 200, 225, and 175 respectively. We can't do these all together because the equation only represents the adult tickets and children's tickets to equal the total revenue for one night. It can't be used for multiple shows. So for my first show, the number of adult tickets that I'm selling is 200. The number of adult tickets that I'm selling for show 2 is 225. And for show 3 is 175. So I know that I have to make $750, and in each of the 3 shows I have a different amount of adults showing up. So it's asking me now to solve for the children's tickets that need to be sold. To solve for the children's tickets, the formula that I would use would be y equals negative 2x plus r, because y is isolated. So I'll write down y is equal to negative 2x plus r. Y is equal to negative 2x plus r. And y is equal to negative 2x plus r. And then we can begin to replace our variables and solve. So y is equal to negative 2 times x. X represents the number of adults, which in our first show is 200, plus our revenue, which needs to be $750. Y is equal to negative 2 times 225 plus 750. Y is equal to negative 2 times 175 plus 750. And then we can begin to solve for the number of tickets that we need in each show to be represented by children. So if I work out the first one, negative 2 times 200 is negative 400. Negative 400 plus 750 is 350. Again, you can type this in all in once into your calculator if it's a 2-line calculator because it does BEDMAS for you. If not, you'll have to break it down into BEDMAS yourself. So first I'll multiply. So negative 2 multiplied by 225 is 450. Negative 450. Negative 450 plus 750 is 300. So then just keep going. Negative 2 times 175 plus 750 ends up being 400. So those are the number of children's tickets that I would need to sell in each show to make a revenue of $750. So now the last question is just saying, what was the advantage of rearranging the equation first? Well, when we rearrange the equation into slope y-intercept form, we have already isolated the y value. So we were already solving for the number of children's tickets. So there wasn't any moving around that we had to do with numbers to be able to isolate that variable. So we'll just say that the advantage for writing the equation first was that we isolated for the variable that we needed to solve for. So right now that concludes our final lesson for the unit. We have 3 lessons again in this unit, all dealing with solving equations and rearranging them in y equals mx plus b.